How to solve problems based on center of mass? Question. A man of mass capital M having a bag of mass small m slips from the roof of a tall building of height capital H and starts falling vertically as shown in the figure. When at a height small h from the ground, he notices that the ground below him is pretty hard, but there is a pond at a horizontal distance x from the line of fall. In order to save himself, he throws the bag horizontally with respect to himself in the direction opposite to the pond. Calculate the minimum horizontal velocity imparted to the bags so that the man lands in the water. If the man just succeeds to avoid the hard ground, where will the bag land? Solution. It is given that the man jumps from the top of a building. Therefore, his initial speed u is equal to 0. Let's assume that the man takes time t1 to reach the ground. Then, the height of the building capital H must be equal to half into gt1 square. We can simplify this to calculate the time taken to reach the ground, t1 equal to square root of 2h by g. Let's say when man throws his bag, he is at height small h from the ground, which means that he has fallen for a height of capital H minus small h. Now, if we assume that time at which he throws the bag after jumping is equal to t2, then the height capital H minus small h must be equal half g t2 square, which on simplification gives us time t2 is equal to square root of 2 times capital H minus h divided by g. Now, the time taken to travel the height small h, that is the time taken after throwing the bag until reaching the ground, t3 is equal to t1 minus t2. During this time, t3, the man travels a minimum horizontal distance of x towards right to avoid hitting the hard ground below. Therefore, his minimum horizontal speed vm must be equal to distance x divided by time t3, or vm is equal to x divided by t1 minus t2. Since while traveling in the air, there is no external horizontal force acting on man and bag system. Therefore, the horizontal momentum of the system must be conserved. In other words, the magnitude of momentum of the man in horizontal direction after he throws the bag must be equal to the magnitude of momentum of bag in horizontal direction. If we assume that the horizontal speed of the bag is Vb, then the mass of man into velocity of man must be equal to mass of bag into velocity of bag. That is, capital M into Vm is equal to small m into Vb. This implies that velocity of bag Vb is equal to capital M into Vm divided by small m. Substituting the value of Vm calculated earlier, we get Vb equal to capital M into x divided by small m into t1 minus t2. Now, substituting the values of t1 and t2, we get the speed of bag is equal to capital M into x divided by m into square root of 2 times capital H by g minus square root of 2 times capital H minus h by g. Simplifying this expression, we get the velocity of bag. This is the answer to first part of the question. Moving on to the second part. If the man was just able to avoid the hard ground, then he must have traveled the distance x in the horizontal direction. And since there is no external horizontal force on man and bag system, center of mass of the man and bag must remain on the same line of initial fall. Let's say the bag travels a horizontal distance y, then we can write that capital M into x must be equal to small m into y, or y equal to capital M into x divided by small m. This is the answer to the second part of the question.
Please like, share and comment on the video, and don't forget to subscribe to our YouTube channel.